happy it's Friday. Because,
One of those weeks.
So we are going to find the standard form, not a standard form, the standard form, meaning we are going to find the exact equation. We are finding a value. We are given a vertex and a point that it goes through. That is enough information for us to find the true equation, our proper equation, everything of it. So we're going to start by taking our vertex and putting it into our vertex form, or that transformation form. Let me lock this. So this vertex, that is our h comma k. We used this yesterday. And we're going to put this into our transformation form where we know our function is our a x minus our h, so x minus 0 squared, plus k plus negative 2, or just minus 2. That is also okay, but it's just substituting things in. Just because that tends to make us itch. So this gives us our kind of general form. That's what we did at the very beginning of yesterday. But since I know a point, I can now solve for a, because I can substitute this piece in for my x and for my y. So to find my a value, I'm going to substitute in this point. My y is going to be that 25 that equals our a. We're going to have our x, which is 3 minus 0 squared minus 2. Substituting in our x and y. Now we can solve this for a. So we're going to have our 25 a times 3 minus 0. 3 minus 0. Not times, minus. It's just 3. So this is going to be 3 squared minus 2. When in doubt, write it out. So our 25 equals, what is 3 squared? 9. So this is a times 9 minus 2. What can we do here to solve this? Add 2. When we add 2, we get that 27 equals a times 9. So how can we figure out what a is? Divide by 9. So what's our a? 3. We have to write it as the equation. Finding the a is not enough. We're going to take this and put it in our equation, which we have most of it right here. So our f of x equals our a, which is 3, times our x minus 0, which we can just write as x squared minus 2. When we're doing our standard form equation, this means no parentheses. Not vertex form, standard form. Do I need to do anything to get rid of my parentheses in this equation? Do I need to multiply anything out?
No.
Nah, it's just x. So our standard form equation is just the 3x squared minus 2. If we had an h value on our vertex, we would need to multiply the whole thing out and then distribute our a, which we will see in a second. We're going to do one like that. But so when we're writing it in our standard form, that's our ax squared plus bx plus c equals y, or f of x, or g. That's this is standard form. Our vertex form, that's our y equals a x minus h squared plus k. So we're going to use both of these forms. Our standard form has no parentheses. Our vertex form does. That's our h and k transformation form. Okay. Questions on this first one? We're going to do another one like it because I know these are a little weird. Okay. So now we're going to find the standard form equation of a parabola that has a vertex at 3, 1 and an x-intercept at 0. So we're going to start with our vertex to put it in kind of our general transformation form. That's when we have our function equals a, because we don't know that yet. We're going to put x minus what? Not 0. 3. X minus h squared plus what? 1. Because again, this is my h comma k, and we're using that vertex form. So we use our vertex to put in that vertex form. How can I use the fact that we have an x-intercept at 0 to help me figure out what a is? More specific, what will we plug in? 0 for x. Will that help me figure out what a is? What is the ordered pair for an x-intercept at 0? 0, comma, 0. X-intercept means y equals 0. X-intercept of 0 goes through the point 0, 0. So if they said a y-intercept of 2, that would be 0, comma 2. If we have an x-intercept of 4, it would be 4, comma 0. So they might not give you the ordered pair, but they give you enough information. So this is the point we need to substitute in to find our a. We need an x and a y. If I'm solving for a letter, I need to have only one letter left. If we have 2 letters, we cannot finish solving it. So this is where we substitute in our 0 equals a times 0 minus 3 squared plus 1. Let's simplify this. So we're going to have our 0 equals a times what? What is 0 minus 3? Squared. 9. So a times 9 plus 1. Yes, dear?
Could you rewrite a times 9 as just 9a?
Absolutely fine. The only reason I have it this way is because my A is in front here, and I was just dropping it straight down. But yeah, totally fine, because I agree that makes my brain go, but I was just keeping it straight line down. What do we do next? Subtract 1. So I have my negative 1 equals a times 9, or 9a. I'll switch it here. Still trying to figure out what a is. What do we need to do? Divide by what? 9. So what's our a? Negative 1/9. Negative 1/9. Thank you, dear. So our a is negative 1/9 here. Whoops, sorry. So then we're going to take it back up into our vertex form equation. So I can finish that guy out and make that complete. Where we have our f of x equals negative 1/9 x minus 3 squared plus 1. And if we were just writing it in vertex form, we'd be done. But we're not asked to write it in vertex form. We're asked to write it in standard form, which means I need no parentheses. So what are we going to do? skip the question is not a good answer. You can do this, multiply it out. Order of operations, we're going to start with PEMDAS. So can I simplify anything inside my x or inside my parentheses? No. Do we have an exponent? Do it. X minus 3 squared. So f of x equals our negative 1/9. X minus 3 squared is going to give us what? X squared minus 6x plus 9 plus 1. Notice how I kept my x minus 3 squared in parentheses because we also have that multiplication out front. Because now we need to do some distributing. That emphasis was weird. Some distributing. Because I need to distribute this minus 1/9 to all three of those pieces. So my f of x equals negative 1/9 x squared. I'm going to give us that one. Our negative 1/9 times minus 6x. What's that going to be? Positive 6/9. Also known as 2/3. 2/3 x. Minus 1/9 times the positive 9. Negative 1. And then we have our plus 1. All right. So one last simplifying step. F of x. Our negative 1/9 x squared stays the same. My 2/3 x stays the same. If I have a minus 1 and a plus 1, what's going to happen? They cancel out. So this is our standard form equation.
Wait, so you can leave it in fractions?
Yeah, we can leave it in fractions. It's only when we were in linear equations that we can't do that. Because linear equations is when it needs to be our ax plus by equals c. That's very different from y equals ax squared plus bx plus c. Because we want to have this y just a y. Otherwise, we'd have a number over there, and that makes things weird. So in linears, we don't want to leave it in fractions. But in quadratics, we absolutely can. Okay. Questions on that kind of question? What's up?
So how do you know?
Say that louder, dear.
How do you know when nothing but different functions? Both of them just says standard equation.
And we did that for both of them. We made no parentheses.
But it's nothing on other like times x squared.
Yep. So on this one, we still got it with no parentheses. That's this guy right here. This was our answer. Standard form has no parentheses in it. That's our goal. No parentheses. This one also has no parentheses in our final answer. Okay? So, we're not using that. That's for linear equations. This is standard form versus vertex form, where we had our y equals a x minus h squared plus k. So this guy's where we started, and we needed to wind up here, where it has no parentheses. Okay? And that's because they told us the standard equation or the standard form equation. Okay, so in the homework, there's a question that has a picture on it that we look at it and we go, So we're going to talk through one very much like it, where we look at this. I made you picture it so you can have it. So we are asked to find the maximum distance between these two shapes. And I gave you the equations at the very, very top. I'm giving you the picture, so if you want to draw on it, you can. They have There's, I believe, question 36 on homework 1 is very, 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 very much like this. Oh, I've got them. I recently went and picked up a whole nother stash of glue sticks.
Can you pass me?
Nobody promises that they're good, because I don't know when they were purchased. But there's some options. Because they've been in that cabinet for who knows how long. All right, we're gonna go. It's entirely possible. Decimal that's from 99, but could very easily be 2010. Just because at some point we did move offices, but they are like way in the back. So, and I think I'm one of the only people that uses them. But I want you guys to have the graphs so you can see them. It makes it helpful. All right, so there is a question like this on the homework, and I want to say it's question number 36. Yeah, number 36 is like this on the homework. Okay? They ask us to find the maximum distance between the parabola and the line in that green region, meaning we're just only looking there. What we're not going to do is start throwing out distance formula. That's not the vibe. Because the distance between my parabola and my line, we can find that distance. Thank you. We can find that distance by subtracting them, right? So if it was, just for example, if we looked at this distance from here to here, I would subtract my 3 minus 0 to find out that's a distance of 3, right? I could go, let's say, here. To find the distance between my parabola and my point here, I would do 3 minus negative 2 to find a distance of 5, right? We could subtract them to find that distance. So to find our maximum distance, what we're going to do is we're going to take our parabola and subtract our line to find our distance. So I have the equation for my parabola. My parabola is this guy because it's got the x squared. So we're going to take our negative 2x squared plus 4x plus 3, and we want to subtract our line. Our line is this equation. So we're going to subtract our x minus 2. You say why? Because to find our distance is the difference between them. Because looking for our maximum vertical distance, that's the distance between this point and this point. So I could take my 3 minus negative 2 to find out that this is probably 5 squares. We could find this vertical distance by taking my 3 minus 0. This is a distance of about 3 squares. I could find this distance by subtracting them if I knew those exact values. The point is to try and find our exact values. Okay, so we're going to take our parabola minus our line to find that distance. Okay. So let's simplify the left-hand side before we start talking about where we're going to do that. So let's simplify this. We're going to simplify this. Minus 2x squared. I don't have anything I can combine that with, so we're just going to have our minus 2x squared. I've got a positive 4x. That's not really important. A positive 4x, and we're subtracting x. So we're going to have plus 3x, and then we're going to have 3 minus negative 2. Positive 5. And that's going to equal that distance. Okay, so this is the equation to find the distance between those two shapes. Now we have to find a distance. We're finding the maximum distance. Where are we going to find a maximum of this function here? Where do we, a vertex. The vertex is always going to be your maximum. So I need to find the vertex of this. That's where we find our maximum distance. The vertex is the max. So not the vertex of our shape there, because we can't guarantee that's maximum distance. It could be that this is our maximum distance, but it could be like here, where this line gets a little farther away. It could be over here, where the line gets a little farther away. So we're trying to find that maximum distance in the green space. So how do I find the vertex of that distance equation? Vertex formula. More specific. What are we going to do? We did a bunch of these yesterday. How do I find my vertex? I was going to say, we can find our y, but first we need to find our x, which we're going to do with the axis of symmetry. We're going to find our axis of symmetry, which is the x value of our vertex, which we get from doing what? What's our formula for it? Negative b over 2a. Opposite of b over 2a. Whatever we need to do. So our setup for this one in particular, what are we going to have? Yeah, so I'm going to set it up with the signs first, but then we're going to simplify. So the opposite of b, so negative 3 over 2 times a, 2 times negative 2, which is negative 4, or that the x is 3/4. So that tells me where my maximum distance is. Is at the x of 3/4. So it's right about here. How can we find out what that distance is? Put it back into this guy. So we're going to take that x of 3/4 and substitute it back in. So we're going to have our negative 2 times 3/4 squared plus 3 times 3/4 plus 5. That's what equals our distance. So let's simplify that. So what is 3/4 squared? 9 over 16 times negative 2? Yeah, either way. You can either do it as negative 18 over 16. Because we square our 3, square our 4, so it's 9 over 16 times negative 2 is negative 18 over 16. Or you can simplify it and realize that is negative 9 over 8. Also fine. Plus 3 times 3/4. What is 3 times 3/4? 9 over 4. Plus 5. So what is our least common denominator between all three of those fractions? I'm not going to be able to get my 9/8, because remember this guy simplifies down to be negative 9/8. I'm not going to be able to get that down to be a 4. So our least common denominator, 8. So this is going to be negative 9/8 plus, how do I put 9/4 in terms of 8s? 18/8 plus 40/8. Putting those into common denominators so that we can have what as our y value? What's our distance? 49 over 8. So it's not pretty, but it's a thing. Huh? Is that our what? That's our distance. So this is the maximum distance between the parabola and the line. Okay? So there's one like this on the homework. We're finding our maximum distance. So we're going to find the difference between the two functions. Then we'll have to find the vertex of that distance. Okay? It's like we have another graph there because we're going to practice reading these graphs and using them for things. It's not a distance question, which is why it only has one shape on it. But sometimes we're given a graph and we're asked to find the equation for it. So this one is not in vertex form or in standard form. We're in factored form or in root form. And they want us to leave it in root form, but they also want us to find the a value. So, what the heck can we do here? Yeah, we've got roots. We can see them on the picture. We have roots at -2. And I have a root over here at +4, right? Put them in our factored form. We know our y equals a times, and we were exactly right, we were saying that before, x minus our root, x minus -2 becomes x plus 2, and x minus +4. So we can read the roots off the graph. But now we need to find our a value. So now we're back into what we were doing at the beginning of the day. How can I find my a value? Plug in 2, 4. I have an x, I have a y. It's on my line. I can find my a this way. So this is just another random point, but it is an x, comma, y that we can use to fill in our graph. So my y is 4. So when we substitute that in, we're going to have 4 equals a, whatever that is, times 2 plus 2 and 2 minus 4. Substituting in that point we have. Now I have only one letter, so we can simplify this. We can solve this. So 4 equals my a times what? 4 times -2. 2 minus 4 is -2. 2 plus 2 is 4. So again, I'm going to simplify. I'm going to do that multiplication. So I have 4 equals a times 4 times -2 is -8. So what's my a? -1/2. Divide both sides by -8. 4 divided by -8 is -1/2. So we're going to put it back into our factored form because they specifically said they wanted a factored form equation. Up here. Find the equation in the form of this. They just didn't call it factored form. So they want this, but with all the things filled in but x and y. So our y equals our a of -1/2 of x plus 2, x minus 4. So it doesn't matter which form it is, we can still substitute in values to find those a's. We can still do that and substitute it in. Okay? Questions on that one? Thus, the benefit of the take-home quiz, we have 10 extra minutes. And I didn't have to floor us through those last couple of questions and speed through it. Can't do that every quiz. But we have some time also because I'm not going to push us forward because I actually had to leave because my kid was sick. So fourth period didn't get me teaching them in front of their face. They had to watch the video because my kid got sick yesterday. So I'm going to be catching them up to you guys. So I'm not going to push you guys even further ahead.
Great.
Okay? So make sure today you turn in quiz 6. That was our take-home quiz from yesterday. I have the unit 2 reviews. I always try and have them the weekend before our chapter test because our chapter test is next Friday.
Yeah.
So I know a lot of us like to have weekend time so we can kind of chill and relax and do it and not try and rush it in the evenings because we have sports and rehearsals and all the other things happening. So I have it. If you don't want it yet, you don't have to have it. Like, I'm not going to make you take it. But I know a lot of us would prefer to do this over the weekend when we have a lot of time as opposed to trying to do it in the evenings. So I have it. I came in early to print it for you since I had to leave in fourth period. I'm going to put them up here. Let's move my little tray over. So I'm going to put them right here. If you want it, you can have it. You don't have to have it. But our chapter test is next Friday, which is the day before fall break. So, just saying. We only have one more section. We have 3.7. That's it. Okay, this was the end of 3.6. Okay? So we only have one more section to do.
Liz, do you want one?
You're so nice. I'm making people
Thanks.
actually walk up here. You're being a very kind friend today.